What's up YouTube? The Disney DVD player is back on the workbench. It gave me some issues, but I got it fixed. Let's get into it. Okay, so the customer approved doing a full recap of the power supply, and we'll be getting into that. I ordered some caps that I didn't have on hand. Some general things to note when you are recapping. The orientation of electrolytic capacitors are important. You'll see there's a white line on each of them. That's the negative leg. I like to go through each capacitor and verify that the white line does indeed line up with the white dot on the board itself, because there could be print errors on the board. In this case, it's looking like every single white line is lining up with the white dot. I've also made a little diagram, just a relative space of where each capacitor is in relation to each other, so that when I put them back in, I know the correct layout. Okay, so there might be a question of what's the actual purpose of this? What are we doing here? What we're doing is replacing capacitors that have too high of an ESR, and that's equivalent series resistance, and I'll explain that in a minute. But you have mains voltage coming in, right? We've got our plug in here, that's the mains voltage. Then we have a filtering mechanism. That's these capacitors, this inductor here. That steadies out the voltage, right? So you've got AC coming in, and there might be some ripples on this, so that filtering mechanism helps steady this out to a nice smooth curve. Then we need to rectify it. And rectifying means that we're taking the negative portion here and we're flipping it positive with these diodes. The diodes only allow current to flow in one direction. So now we have these blue humps here, but that's not very steady voltage. What we do is add a capacitor, and that's what this black line represents, is this capacitor fills in the dips. When we see a dip in voltage, that capacitor is like a storage bank, and it just gives a little bit of extra push. So you have more of a steady line across this instead of these humps. Once that's rectified, we switch and step down. This transistor here switches on and off that voltage at thousands of times a second, and you get this kind of chop. Some people call it a chopper transistor. You get this chopped curve here. And that allows us to use a transformer to step down the voltage to something lower, maybe like 16 or so. And then you have individual branches here that tap off of the transformer and get different voltages. But since now we have, again, an alternating or a chopped voltage signal, we need to rectify that again. That's what these diodes are for. And once we put in these capacitors, you get a somewhat flat signal that's a steady voltage that processors and everything in the system can use. Now the ESR, what is ESR? Equivalent series resistance. An ideal capacitor would just have a capacitance. But because we live in reality, every capacitor has its capacitance and a small resistance associated with it. So if this resistor, the ESR, gets too high, it starts resisting too much current, and we start losing this steady voltage that we obtained when the ESR was low. So if a cap gets an ESR that's too high, we're going to replace it. Caps just do that over time. The electrolytic caps, there's a fluid inside here, it'll dry out and the ESR starts creeping up, and we're going to replace them to drop it back down to get a steady output voltage. That's what we're doing. So these are the ones I just removed. If we look at this one, it's supposed to be 2.2, which it does read about 2, so that's good. The ESR 12, that's a little high. This one 82. So
718 milliohms, that's fine. But again, we're replacing them with better quality, higher temperature, should last longer.
Okay, when removing this one, this trace here tore this pad, but luckily the trace is pretty fat behind it, so I scraped back some masking. I think soldering the end, that's gonna hold just fine. This is continuity checker. I'm gonna check a pad right next door. Yep, so we got continuity. This is what I was talking about, how the disc tray has to come out for you to get this cover on it. So when it was completely dead, it took forever to try to slide this thing off. Okay, all back together. Let's plug this in. Get the TV. Oh, the power's not on. That would help. There we go. Power on. Tray open. Or is it? Yeah, so this is where the trouble started. After power cycling, the device decided to turn on. Disc in. Alright, cover the screen a little bit so we don't get a copyright strike, but it's playing a disc. I think we got that finished up. Update on the operation. So, all the capacitors were replaced. It powered on, it functioned fine once. And then, every time I try to power it on, not every time, but I'd say 1 out of a dozen times it would actually turn on. The other 11 times, it would make a weird buzzing noise from the transformer here. I wasn't sure exactly what was going on. I didn't think it was anything on the secondary side. So I figured it was something on the secondary, and the only two things I touched on the secondary were the bulk cap And I thought this was a starting cap or something, but it's actually connected to this switching MOSFET here. So I think it has something to do with a snubber circuit. I was surprised to find the schematic for this device online. If you look at C1003 that I've put in this box here, it is a part of a classic RCD snubber. At least I now know what the capacitor was. I put the original one back in. The one that I used to replace, I don't know, something about it, some property just doesn't work out when it's in the circuit. But right now, it powers on, it functions every single time. I think I'm gonna leave this one in and we're gonna call it a day because I really don't wanna take this thing apart again. I had it all together and then it started doing this weird hiccuping, buzzing thing, so it's all back apart again. But I think we got it. If it was my device, maybe I'd do some probing with the scope. I'd swap in the new one that I bought, see how that compares to the old one in terms of maybe ringing or the stability of the switching, but this is not mine. I don't have time to play around and mess with it. I want to package it up, confirm it's working just fine, get it back to the customer, and move on, because I've got other local repairs that people want me to handle, and I don't have all the time in the world to do this. This is what I do on my off time. If you like this content, please hit the like button, click subscribe, and I'll see you on the next one.